So we hear a lot about digital transformation, and there are a lot of definitions out there. And a lot of it boils down to harnessing the power of data. Many companies are asking questions like, how can we access more of our data, make the most of our data, provide a single source of truth for production data, provide context, and make that data accessible to the entire organization? How can we bridge the divide between OT and IT and minimize or eliminate manual data entry and coding? And how can we do it without spending 6 months and blowing through our budget? There's a good chance that you're pondering those questions too, and that is what we want to address here today. To fully unlock the power of data for digital transformation and to lower the factors of risk, complexity, time, and cost, we need to solve operational challenges first by modeling and adding context to our data. This is an effort to standardize data across your entire organization. So we're talking really today about two concepts: data modeling, which is the process of structuring data in a unified way to make it easy to understand. And we're basically modeling real-world objects out there, like compressors and lathe machines and CNC machines and a lot more. And of course, data modeling is very, very important to IT. It's also very important to the OT world, but it's not properly supported by most devices and edge systems in the OT space. So it's a very important concept, though. We have to be able to define our data models from OT that we can bring all the way through our business and into higher-level systems. We also need to provide context to that data. Why? Because information without context is just numbers. OT data has no contextual information typically from the devices themselves, but all of the domain experts have that information, and that we need to be able to provide that information in one location so that IT can have the information and business systems can have the information and automatically discover that. And this is one of the problems with bridging the OT-IT gap, is that we lack the tools and or the standardization of being able to have the proper models and the proper context of our data. So Ignition really is the perfect tool for data connectivity. It allows us to connect to all of those plant floor devices, all different PLCs, through native protocols, as well as supporting standards like OPC, to bring that data into Ignition, to be able to transform and map that data to these real world objects with all the context that's there. Context like engineering units, what the range of that value is, what asset information that's coming from, what is the model of that data. All this information is really, really important. And we want to be able to provide that mapping in Ignition in one place and get that information up to high-level systems. And so to talk more about that, I want to pass it over to Arlen to talk more about how to standardize data across the entire organization.
Thanks, Travis. Like you said, Travis, we've been doing this for the last 40, 45 years. And we are in the process of taking all of that brownfield legacy knowledge that we did in OT, and how in the world do we bring that up to something that's contextualized that the rest of the enterprise can start using in their digital transformation journey. So, I'll give an example from many, many different industries. I literally was on a call yesterday with a food manufacturer, and they've got several plants, and they have slicing machines. They slice cheese, they slice meat. Well, each one of those machines had a different enumeration of the state of the slicer, right? So 012 for this machine was different than 012 for that machine. So all of a sudden, we've got all of this data, but we don't have any context to it. To your point, engineering units, engineering ranges, what do enumerations mean? So if we could take that data and have the tools to organize it, to bridge not IT down to OT, but to bridge all of that tribal knowledge that we've got in OT and be able to bring it up. And one of the popular kind of monikers that have been put on this is that, this is called a unified namespace. What if we could imagine that we had an infrastructure that instead of connecting from applications to devices, like hard coding that, what if we could just plug devices into our infrastructure? They could publish their information, and we could automatically plug and play and discover all that information. Now, as I believe everybody knows, Cirrus Link is quite involved with the MQTT, and what we've come up with is the Sparkplug specification. Now, in a lot of the talks that I give about MQTT, I say that the great thing about MQTT is you can publish anything you want on any topic. But the bad thing about MQTT is you can publish anything you want on any topic. So Sparkplug is a specification that looks to set on top of MQTT. It doesn't change MQTT. It just says, hey, if you want to use MQTT from an OT to IT perspective, we need to define an OT-centric topic namespace. What does that mean? That means that when we go and we subscribe to an MQTT broker, we know what topic namespace to look for. And then within that, within the other part of MQTT, you have your topic namespace, but then you have your payload. So MQTT Sparkplug defines the data model, the asset structure, and the process variables for the payloads that are being published in these MQTT messages. Now, Sparkplug does go a bit further. It helps us define the state so that we know the state of all of our MQTT devices at any point in time. And it really helps us establish that single source of truth, if you will, for anything that's going on in the enterprise. So now let's take a look at this. If we've got the Ignition platform, which you're going to demonstrate here in a little bit, and we've got the tools without having to write any code, and we've got the ability to publish a model, a twin, and a measurement, then what if we look at some of the services that Microsoft offer? So what we did was we took our knowledge of Sparkplug and our knowledge of the way that the Ignition platform works, and we developed IoT Bridge for Azure. And what IoT Bridge is this a service that can subscribe to an MQTT broker on one side, and it knows how to create automatically in Azure Digital Twin the digital twins. So you literally, from a no coding aspect, you can automatically discover all of the digital twins and the models that they're built out of. And then you can take that template, publish it, and literally build the models in Azure Digital Twin, and be able to take all of the real-time data that's being published on report by exception and flow that directly into ADX. And I want to be able to do that in as little time with as little effort as possible going forward. So given that, we'll go into what the topology looks like here. So if you can imagine you've got an Ignition platform, it's sitting on your plant floor, it's sitting out at your remote assets, it's out there, and you've already started to work and bringing, with all the tools that Travis showed you a while ago, the OPCUA, all of the native protocols, the ability to bring all that data into Ignition. Now you can start building UDTs, or what we're calling a digital twin. Once you've built the model, you can instantiate and reuse that UDT many, many times. You started to standardize your representation of the machine. So now you literally can very simply connect the MQTT transmission module to an MQTT server. Now, IoT Bridge can run anywhere. It can run in your Azure infrastructure. So on the left side, it knows how to subscribe to these MQTT messages being published. On the right side, it knows how all of the APIs to be able to take those and create, first of all, the model in Digital Twin, and then the instances of those models, it creates what's called the digital twin. So now, with one easy step, we created a model, we've instantiated it, creating a twin, and then using Event Hub, we can take all of the real-time process variables that are changing and get those directly into Azure Data Explorer. So with that, Mike, and that, given that topology, what do you see that Microsoft can start doing with that?
Yeah, thanks, Arlen. I think, you mentioned Azure Digital Twins and Azure Data Explorer. Let's quickly explain what those are for those that may be unfamiliar with these services. First off, Azure Digital Twins, or as you refer to it, ADT, is an Internet of Things platform that enables you to create a digital representation of real world things, places, business processes, and people. First, with ADT, you can create comprehensive digital models of your entire environment and bringing in that context, like you mentioned. So for us, maybe that means we're including relationship mappings for things like this machine is part of this cell or part of this line, and in this plant, like you'll showcase later. Next, you can track in the past and help predict the future and across any connected environment with native integrations across other Azure services like Azure Data Explorer, which we'll talk about. This in turn helps you break down data silos within connected environments across the organization. And then, of course, it's built upon a trusted enterprise-grade cloud platform. Next, we have Azure Data Explorer, or as we refer to it, ADX. It's a big data, fully managed platform optimized for real-time analysis of this scenario and telemetry workloads. ADX has a few specific built-in services that are essential for digital transformation, such as time series analysis and anomaly detection. There are also specific dashboards built into the service so you can quickly analyze the data flowing into ADX, maybe query that data from ADT, or since I know not every manufacturer has large data science staff, you can actually leverage other services like Metrics Advisor to quickly activate machine learning models to do root cause analysis. And then finally, it has native plugins for other services like Power BI, Grafana, Databricks, and other APIs, depending on maybe where your visualization needs to occur, other services you want to bring into the fold. Back to you, Travis.
All right, yeah, thank you, Mike. And so with all of this we're talking about here today, and what it boils down to is being able to provide a single source of truth of our systems. And so cloud services like Azure and open standards like MQTT and data models are making it possible to really have this single source of truth, the production data that is accessible throughout the entire enterprise. And Azure Digital Twin can also be used to realize data models built on the edge automatically with no code, as Arlen was saying. And so it's really tools on platforms, not coding operating systems, that's really important here. And we're looking at OT, all of that domain knowledge, all of the information, all of those assets and those models are known there. And if we can provide that mapping and create those models with context in one place and have it available throughout the entire organization, leveraging these standards, it makes our journey, to get to Industry 4.0 a lot easier, a lot more approachable.